Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithm series. In this video, we are going to implement a generic solution for topological sort. Now, what is a topological sort? Topological sort is basically sorting of directed graph. What is a directed graph? A graph where there is a direction defined. So starting with the node 0, there is an outgoing node 1 and 2. For 1 and 2, there is outgoing node 3, and for 3, we have two outgoing nodes 4 and 5. So for any graph or topological sort to be implemented, the graph need to be directed. Now, to start this, first we will be implementing the directed graph in part 1, and in part 2 we will be implementing the topological sort itself. So let's begin. So we write a trait for graph with a value v, with a type of v. So first method will be vertices. Vertices will be sequence of elements. Vertices are basically the node of the graph. So what all nodes we have, we will be having in a sequence of vertices. Let me correct this spelling here. Now second method will be we will have edges. What are the edges? Edges will be a sequence of value, that is a pair that will tell us which all values are associated or the direction. So this will basically give us the direction or the to help to make the directed graph. So this is basically tuple of vertices. So which node is associated to which, we will know by this. Now we need to have a method to add the edges. It will have two values. First will be the node and second will be the value that is being added, and it will return a graph. So basically this is to add an edge to a node. Third method would be neighbors. So we will require this. It will be basically to sort, we will need this. Sorry, it will be of type, it will be vertex here, and it will be of type V. This will return a sequence of elements. So every node will have a sequence. Basically we will be using adjacency list here. So neighbors will give me all the neighbor for a particular node. Now the third or the last one is our topological sort. This will give us a sequence of vertices or the nodes, which will be basically our method that will return a topological sort. So now graph is in place. Next thing is we need to have a directed graph. So directed graph will be of type V, that will extend, or that will first it will need an adjacency list. It will be of type map of V comma sequence of V. Now this will extend a graph of type V. So I hope you guys are following. Now we are implementing a directed graph. Now as we see, there is a correction here. So let's implement all the methods. So we'll be implementing all the methods here. As you see, the last one is our topological sort. So first method, the vertices. What all vertices do we have? So this will be basic, nothing much. Adjacency key list dot keys dot to list. This will return the list. Now what is our edges? What are our edges? So adjacency list, so this will have, basically this will contain a sequence of values. So we need to break the adjacency list and get this combination as a pair. So how we are going to do it? So we have adjacency list and we will do a flat map. So if you know about flat map, we will be applying flat map, and when we apply a flat map, it will give us a value in form of tuple. The tuple will have first this value. So now we are getting a value. First component is what we call as the vertex and their associated neighbors. So the adjacency list is basically a combination of a value and a map of basically the value, the node, and the sequence of dependencies. Now as we have this, so it will be neighbors dot map, and we have the value, so we will mark it as it's going to be tuple, and it will be dot to list. So now we got this as a list. Second is add edges. To add edges we need to add them. So val neighbor of a is equal to b neighbor of a. So now we are appending the value to our existing map. So we created a new sequence appending a value b to it, and we will pass it to our directed graph. So our directed graph, we don't need a type because we are defining it inside. It will get the type automatically, adjacency list, and we will be appending it as a comma a neighbor. So now we are appending the value as we are creating a new adjacency list out of it. So this is how it is going to be. Now we have another method called override neighbors. This will give us a sequence of value. So as we can see, the adjacency list, and then get or else, it will give us the sequence, the value, get or else, and what it is going to give us, because it's always going to be a tuple. So vertex comma nil. So this is what we are going to get out of it. So adjacency list will have the value. So this is a map. So whenever we pass the value, it will give us that particular value or nothing. Okay. So now we have this topological sort. So this we are going to implement in next video. Meanwhile, there is one component that is left. Okay. So we will be doing this in our next video. If you like this video, please subscribe and please click on bell icon for any further updates. Thank you.